this is Stephen DeMarney, and today we are going to learn some basics about solderless breadboards. Here is my solderless breadboard. You can see it has lots of holes in its plastic frame. It has 400 holes to be exact. The white plastic frame is an insulator. Under each hole is a conductive spring that is designed to grip a wire when it is inserted through the hole. This spring is very similar to the knife switch spring jaws in shape and function, which you see here. Here I am showing you the knife switch spring jaws in a side view and how I can insert a component lead into the jaws and how the jaws hold the component. So now here I am I'm pushing the conductor wire in, and you see it's holding the component wire in the spring jaws, and then I can also remove the component out of the spring jaws. That's how the spring jaws work in the solderless breadboard, but this is just a much larger spring jaw. Now I am demonstrating inserting a conductor into the hole on my solderless breadboard. The conductive spring jaws are just below the hole, and they're much smaller than the spring jaws of my knife switch. The conductor is held in the jaws until I pull it out again. So here I'm pulling it out again. Now the solderless breadboard is arranged into isolated groups of conductive spring jaws so that we can make distinct interconnections between different components or between different leads of the same component. This breadboard is arranged into columns and into rows. And the columns and the rows are separated from each other by the white insulated plastic. So wherever you see plastic between rows, they're insulated from each other, and plastic between columns, they're insulated from each other. Now on the left, we have one conductive column of spring jaws that are all interconnected. This column has been labeled positive. You see a plus there, and that means positive. And it has a red line running down beside the conductive column. Just as an example, I'm going to connect a conductor in the first hole of this positive column. I'm going to insert another one in the middle, and then another conductor on the bottom of the column, of the positive column. Now all of these are connected together by the conductive spring jaws in this column. So all three of these wires are connected together even though they are very far apart. Now I'm going to remove those. Just to the right of my positive column, we can see a negative symbol, or a minus as some people call it. And this column is also interconnected, and you can see it's got a blue line beside it, and that's to signify that all of these connections are interconnected for a negative polarity, and this happens to be the same polarity as what our batteries use. We have a positive lead and a negative lead for our battery, so this is very handy for power supply connections. Like I mentioned before, the positive and the negative columns, they are separated from each other by the white plastic of the base. So they're insulated from each other. So there's no short circuit between the plus and the minus. Notice that we have another positive column and another negative column on the right side of our solderless breadboard. Now these are just like the columns on the other side. They are all interconnected for the entire length, and they're also insulated from each other. But another important thing to know is this positive here is not connected to this positive here, and this negative here is not connected to this negative here. If we want to connect them together, we will have to put a jumper. And so I'll just do that. If I want both my positives to be connected together, I have to put a jumper wire in from the positive there to the positive there. So there I've got my positives interconnected. And same thing for my negatives. If I want my negatives connected together, I have to put a jumper between my negative columns. So now I have a jumper in there, so my negative is interconnected by a jumper. Now we will look at the rows of our solderless breadboard. So you can see we have numbers here, 1, 2, 3, all the way down to 30. So this is what we call row 1. And we also have letters for the different connections for each row. So you see we have row 1A, row 1B, row 1C, D, and E, and row 1F, G, H, I, and J, and so on. So each row has those. But notice this groove here. So there is no interconnection. So A, B, C, D, and E for row 1, these 5 are all connected together. But they are isolated from row 1, F, G, H, I, and J. And each row is also insulated or isolated from each other as well. So row 1 is isolated from row 2, row 2 is isolated from row 3, and so on. Now what is the reason for the isolation between row 1 on this side and row 1 on this side, and so on? And what is the reason for isolation between row 1 and 2 and 2 and 3, and so on? Well, the reason is this board is designed for components like this integrated circuit I have here. And so the integrated circuit goes across the groove, and then you have to push it in, and then this is what we call an 8-pin integrated circuit. And so now pin 1 of my integrated circuit is in row 1, pin 2 is in row 2, pin 3 is in row 3, and pin 4 is in row 4 of this side. They're all on the E column. And then on this side I have pins 5, 6, 7, and 8, and they're on this side of row 4, 3, 2, and 1. The reason for this separation or isolation between the rows, and also each row isolated into 2 parts by the deep groove, is to allow the insertion and use of integrated circuits into the solderless breadboard. Each pin usually serves a unique function, so we want each pin electrically insulated or isolated from each other when it is inserted in the board. Now, if I need to make an electrical connection between pin 1 and pin 2, then I just put a jumper, insert a jumper between row 1 and row 2. So now I have an electrical connection between rows 1 and 2 for my integrated circuit. If I need an electrical connection between the left and right of row 1, I simply need to insert another jumper into row 1 of the left side, and then I can insert my jumper in to row 1 on the right side. So now I've made an electrical connection between row 1 left and row 1 right. Another important thing to remember with solderless breadboards is to use the right kind and diameter of wire. First, always use solid copper conductors. There are stranded conductors out there, but they are not easy to use to insert into these boards, and stray strands can cause short circuits. Second, make sure the wire you use is the right size to fit into the board spring jaw connectors. In North America, we are using the American wire gauge for sizing electrical conductors. The ideal gauge for this board is 22 AWG, and that's what this wire or conductor is, 22 gauge. And it inserts nicely, and it's stuck nicely into the spring jaw. And we can use 20 AWG as the largest and 29 AWG as the smallest conductor for this breadboard. Using conductors that are too big can damage the spring jaws by forcing them too far apart. Wire that is too small in diameter will not have enough spring jaw pressure on it to make a good connection. For metric sized conductors, solid conductors that are in the range of 0.2 to 0.5 millimeters squared are ideal for this board. Be sure to read the instructions from your board manufacturer and use the wire sizes that they recommend. That is all for our lesson today. Our next lesson, number 7, will use the solderless breadboard to demonstrate making a circuit with incandescent light bulbs and LEDs. Bye for now.